Hello everyone, nice to meet you in another video here on YouTube. If you haven't subscribed to my YouTube channel, please be kind to do that right away. So in this video, we are going to talk about recursion. If you find recursion as a difficult topic to understand as a programmer, you are in the right video because in this video, we are going to take a look at the different parts of a recursive function. We are going to also analyze different recursive algorithms such as the factorial and the Fibonacci algorithm. So we are going to use recursive functions to solve them. So let's get started. So what is a recursion or a recursive function? A recursion is a function that simply calls itself. So let's say I have a function here, I'll call it recall. So to make this function recursive, I just have to call this function again inside of it. So I'm going to come down here and call this function again so that this line of code we have written be executed when we run this particular file. So let's come to the command prompt and run the code. So now we are having an error saying maximum recursion depth exceeded. So it means recursion is like a loop. So means recursion, the function was calling itself over and over again until it gets to 906 times. So this error is basically specific to Python. So Python won't allow your recursive functions to run more than 906 times. So it throws an error saying the maximum recursion depth has been exceeded. So let's come over to VS Code to start analyzing recursive functions. So I'll start here by passing a parameter, passing x. So the first part of recursive function I want to talk about is the terminal condition. So the terminal condition is a condition that is meant to terminate your recursive function. So I'm going to write a simple terminal condition. So if x is equals to 0, so I'm going to just return. So the return keyword will help us to terminate this function when this condition is met. So the function will stop calling itself. So when this condition is met, so this recall will never be executed again. So now we are going to pass here an argument of x minus 1 so that we are going to decrement the value of x anytime this recursive function is called. So we are going to pass in here the value of 5. So let's print the value of x so that we can see something in a command prompt when we run the code. Let me put a space. So let's clear the screen and run the code. Wait, sorry about that. Sorry, I was printing 5. Let's do that again. What am I having? Okay, now we have 5, 4, 3, 2, 1. So this is in the order in which we passed in the variables. So I'm going to talk about, okay, before we go further, let me create some comments here. This is the terminal condition. And here is the function call. So now we also have another part of a recursive function, a recursion. So the other part is the return value. So where can we find that return value? The return value is simply the value you get after your recursive function has been called. After all your recursive functions have been called, so it's time for them to return their value. So we can get that by just doing a print statement here. So print the value of x. So let's run the code. Now we see that we have 5, 4, 3, 2, 1, then 1, 2, 3, 4, 5. So these are the first values that were stored, and these are the return values. So let's create a comment here. return value. So you can notice the order in which this stuff was printed in the command prompt. So that will bring us talking about what a stack is. So I'm going to pull up my drawing tool now and show you and use that as an explanation. So a stack is like a data structure that stores in values. So when you want to get the values from your stack, you do a last in first out. So you are going to be able to get the last value that just got out of your stack. So in this case, in the first instance, when we call the function recall here, so recall store the value of 5 followed by 4. So it stored it in the stack. So when we want to get the values back, we started getting return values from the bottom. So 1, 2, 3, 4. I've gotten a pen. So 1, 2, 3, 4, then 5. So that's how we got the values when we return. So that's why this stuff was being printed in the command prompt. So let's go back to VS Code to continue. So over to VS Code. Now there are various ways in which you can write this recursive function. We can also use the return keyword. So in place of putting a print statement here, we can use the return. Can just return this the call. So when we return the call, the print statement we had here, the print value. So the value of x that will be returned, we get it through this return statement that we have here. But we can't actually use a print statement. We can't actually write any code beneath the return. So that was just for analysis. So let's go over to analyzing an algorithm written with recursion. So we are going to write a Fibonacci. So we are going to write a factorial algorithm first. So we analyze how recursion solves it and other parts of the factorial function. So let's create a factorial function. So we pass in a parameter, we pass in x. So we are going to say if x is equals to 1, so that's the terminal condition. We are just going to return, we're going to return x. So next, what we are going to do now, we are just going to return the, the factorial of x. That is, we are going to multiply x by the previous value. So factorial is like multiplication of the previous values of x. So what this we actually do is that anytime this code, anytime this function is called, it's going to subtract 1 from x. So in the first function call, the value of 5 will be stored in the stack. So for after that, the value of 4 will be stored in the stack, followed by 3, then 2, then 1. So let's print out the factorial of 5. So let's do that. So okay, I suppose comment this out. So the factorial of 5 now is 120. So that should be mathematically correct. So now let's analyze this stuff here. So how do we analyze this? So we are just going to do a print statement here. Print the value of x when when we are storing the value of x in the stack. So I'm going to remove this return and I will store the value, the calculation. I'll store it in a variable called f. So f is equals to this calculation here. Then I'm going to print the return value of x when the operation is being done. Then I'm going to then return f. So now let's run the code. Let's clear the screen and run the code. So now we are getting 5, 4, 3, 2, then 2, 3, 4, 5. So in the first iteration or in the first call, before we when we called the stuff here, 5 was added to the stack followed by 4, 3. So when you want to do the operation, you get 2, 3, 4, 5. So now we can also print the value of f to get the calculation when we are returning the values. So let's print f. So I'm going to put some text here in order to differentiate them. Current sorry current value is. So let's run the code. Let's clear the screen. So now the current value is 2, then the current answer is also 2. So in the return value, take note that all this stuff already in the stack. So it's starting to do the calculation now. The current value is 2, and the current answer is 2. The current value now is 3, then the current answer is 6 because 2 times 3 is 6. So that's the calculation it's doing here in this line. So the current value now is 4, the current answer is 24, the current value is 5, and the current answer is 120. So that's how recursion solves factorial. So I hope you understand that. Sorry. So let's create the Fibonacci algorithm. So fib. So I'm going to pass in parameter x. So I'm going to say if x is equals to 1 or x. So the Fibonacci space or the Fibonacci algorithm has two conditions. So we just return x. So we have two conditions because we are going to be having two calls. So at a particular time, one condition will be met. If we do meet both conditions, we are going to run into an infinite call. So we don't want that. So let's complete the algorithm. So we return fib of -1. Yeah, we are going to be adding fib -2. So now if you don't know what the Fibonacci algorithm is, it's simply an addition of the last two digits. So if we start from 0, we are going to just say 1. Then the next value will be 1. The next value will be 2 because the addition of 1 plus 1 will give us 2. The next value after it will be 3 because addition of 1 plus 2 will give us 3. So it's just the addition of the previous two values. So let's let's not forget to comment this out. So let's let's run the Fibonacci. So we just try to get the Fibonacci of 5. So print that out. Can we are supposed to get 8 as the answer. So we are getting 8. So now the Fibonacci algorithm is a bit different from the factorial because we have two function call. So this should be like in a tree format. So I'm going to pull up the drawing tool again. Okay, before I pull up the drawing tool, so let's do some analysis here so that when I pull up the drawing tool, we're able to understand what is going on. So let's print the value of x. So remember, we are having two calls. We are having two calls here. So take note of that. So I'm going to store the value, the return answer in f. I'm going to store the calculation when it's returning. So take note that when it's returning from the stack, that's when the calculation will be performed. So we can now print the value of x. So we can now return f. So let's run the code first. we're also going to make some modification tag. So the first value that entered the stack was 5, 4, 3, 2, then 1. So we are not getting that here. That was because we didn't actually put this in above this stuff. So when you got to the terminal condition, take note, because we don't have any print statement inside the terminal condition, this function stops running, but we still have the return value of the function. It will still be calculated. So we just have to take our print statement above it so that our print statement will be called. So let's run this code again. Let's clear the screen. So now we have 5, 4, 3, 2, 1 coming in. So we have extra stuff going on because we have multiple calls. So I'm going to put some print statement now denoting these different values. So I'm not going to um, put a text behind this X. So we are going to leave that one blank. We are going to add some print statement. We are just going to print the value of F. So we are going to put a text before this one saying this is the current return value. So current return value is this. Then we are also going to do that for F, current answer. Let's clear the screen. Okay, now you can take note of this print X here. This print X is, we didn't actually denote anything with that. We didn't put a text behind it. So we have 5, 4, 3, 2, 1. Then we also have 2 here. We have 3, 2, 1. Then we have our final answer being printed. So that's it. So it means at a certain call, the recursion started again from another tree. So it will be like a tree. So I'm going to pull up my drawing tool now to show you, to analyze this stuff so that you can understand better. So let's go over to my drawing tool. So I've already done the drawing. So it's just to start explaining the stuff. So what really happens is that in your first call, you- we have a value of 5. So that's the 5 we have in here. So this 5 is that 5 at the top. So the Fibonacci has two calls. So it's going to split into two sides. So 4 and 3. So it's going to -1, then -2. So it's just going to split into two sides. So this side we actually have to wait. So this side will wait. So this side that is -1, we just go with the -1 first because that's the first function that was called. So followed by -1 again, that we get 3, followed by -1 again, we get 2. So since 2 is in the terminal condition, we just stop there. So we are also going to now check 3 because 3 is the one that is close to us now. Then we get 1. So that's how we get 1 here. So now when we want to get the return value, since 2 and 1 is here, if we had printed it in the middle, so in that terminal condition where we have the code, let me just go back to the code. In the code, when we have this, if x is equals to 1, if we had created a print statement there, we get the current value at that time. So we have the return value of 1 and 2, but we won't be able to print it because it already terminated there. So I just want you to take note of that. So let's go back to the drawing. So now the current value is 3. So the current answer will be 3. Why is that? Because 2 plus 1 is 3. So that's the return value. That's what I was trying to explain. The return value now, since it's in the terminal condition, the return value is 2 and 1. So the current answer now is 3. So 2 plus 1 is 3. So it's that doing the calculation. So now you can see now we have 2. So 2 is an input value, is another input value again. So it means another session of a Fibonacci call is coming up again because we have two sides, we have two calls. So 4 has two calls. So another session of the call is starting again. So it's going to check the terminal condition. So that's why we have 2. So it got to this, then we have 2. So the current value now is 4 when the current value before was 3. So now the current value is 4, current value is 4. So he has to check 2. So 2 is an input value. So it's in the terminal condition already. So the current answer now will be 5 because 2 2 plus 1 plus 2 give us 5. So the current answer now will be 5. So now after 4, the current value now will be 5. So that is not printed here, but the current value now will be 5. So it has to check 3. Has to check 3. So 3 has function calls of 2 and 1. So it has to pass 3 to 1 again. It's another function call. So the current value now will be 3. So that was printed. So the current answer now for that new call will be 2 plus 1. So remember I told you 5 was split into two sides. So 3 has to wait. So 4 completed its side before 3 will start. So the current value for 3 now, the side of 3 is 3. So now the current value now is back to 5. So when you get the answer, you get 3 from this side, then we got 8 from this side. So sorry, we got 5 from this side. If I can erase that. So we got 5 from this side. So the sum will give us 8. So that's how the Fibonacci algorithm actually works using recursion. So when I actually first saw this algorithm of recursion solving Fibonacci, I didn't actually understand how to actually solve Fibonacci. So I hope you actually understood what I was trying to pass across. If you have any question or any doubt about this video, you can post it in the comment section below. And if you want me to do a tutorial on any topic, you can also drop that in the comment section below. And don't forget to subscribe to my YouTube channel because it helps my video to come up to reach out to a lot of people. So thank you for watching. Bye bye.